Archimedes principle. The buoyant force is equal to the weight of displaced water. That is the key phrase of words of Archimedes principle. And here is an activity to explain Archimedes principle. In figure 1, there is a Eureka jar filled with water. Object is hanging with a balance and there is word LB is written. LB comes for foot, pound, second system. There are three systems for measurement: MKS, meter, kilogram, second; CGS, centimeter, gram, second; and FPS, foot, pound, second. LB comes for foot, that is third system, and this balance shows weight in air in diagram 1, and that is 7 pound. When object is placed inside water, the needle comes to 4 and the difference 7 minus 4, that is apparent loss in weight when object is dipped in water in figure 2, and this is equal to 3 pound. Therefore, upthrust acting on object placed inside water is having a value 3 pound, and if the water displaced is measured, that is coming also 3 pound in outside watch glass. This water weight is the displaced water, and in Archimedes principle, apparent loss in weight, that is weight in air, figure 1, minus weight in water, object is placed in water, that is figure 2, is equal to 7 minus 4 is equal to 3 pound, that is equal to upthrust, and this upthrust is also equal to weight of displaced water, that is 3 pound outside the Eureka jar in watch glass. In this figure, again the activity is proving, and in the figure 1, water is filled in a beaker. 10 kg object mass is hanging and its weight will be 10 kg weight. Then reading in the first figure is 10 kg weight. When this object is dipped inside water, in the figure 2 it reduces and then it is coming to 6 kg weight, that is weight of displaced water is also 4 kg weight shown in figure. Then apparent loss in weight, that is 10 minus 6 is equal to 4 kg weight, that is equal to buoyant force or upthrust force. Upthrust is also known as buoyant force, and this is equal to weight of displaced water, that is 4 kg weight. Archimedes principle. When a body is immersed or dipped partially or fully in a fluid meaning is liquid or gas, it experiences an upthrust that is equal to the weight of fluid displaced by it. Here is fluid word for liquid and gas both, because we know that wooden boat float in water, that is in a liquid. Helium balloon goes up in air, that is gas. Therefore, general word fluid is used here. 1 liter is equal to 1000 centimeter cube. 1 meter cube is equal to 1000 multiplied 1000, that is 10 की power 6. There are 6 zeros, 3 and 3, total 6 zeros, then 10 की power 6 centimeter cube. Or we can conclude that 1 meter cube, if we have a vessel 1 meter cube, L length 1 meter, breadth 1 meter, height 1 meter, that is a cube of volume 1 meter cube, and water is filled inside it, then total volume of water inside this vessel will be 1000 liter. Therefore, this is the relationship between meter cube and liter. Both are the units of volume. Activity to verify Archimedes principle and find the weight of floating body. Here we are having different observations. We have discussed already in the first slide weight of object in air, that is W1, gram weight. Weight of object in water, W2. Then formula for apparent loss in weight is equal to weight in air minus weight in water, and we have discussed already this thing in the first 2 slides. Upthrust of the water on body is equal to loss in weight, that is W1 minus W2, that is apparent loss in weight, not real. Number 5th, volume of water displaced, V1 minus V2. If you are calculating in ml, or ml means milliliter, or cc means centimeter cube. Then number 6, weight of water displaced is equal to V1 minus V2 multiplied density of water, that is 1 gram per centimeter cube. Then finally we are calculating weight of water displaced in gram weight. Point number 7, definition of density. We know mass per unit volume is known as density. Therefore, formula of density is equal to mass upon volume. Number 8, verify Archimedes principle, or here apparent loss in weight, that is W1 minus W2, we have discussed earlier, is equal to upthrust, W1 minus W2 is equal to weight of water displaced, that is W3, and all the 3, that is W3 is equal to W1 minus W2, since all the 3 above are equal. Means apparent loss in weight is equal to upthrust is equal to weight of water displaced. Then this verify Archimedes principle. Number 9, apparent weight of the floating wooden block. A wooden block is floating in water. Then what is the apparent weight? Here upthrust is equal to weight. Both becomes equal. Therefore, the resultant weight becomes 0. Principle of flotation. This principle states that the weight of floating body is equal to the weight of the fluid displaced. Now let us consider the 3 cases. Number 1, here in the figure, a submarine is inside water, sea water. There is a chamber inside the submarine, and with the help of a pump, water is filled inside the submarine. Then weight becomes more than upthrust. Let us come to point number 1. When the weight of body is more than upthrust, then body sinks. Sinks means goes inside water, that is submerged. in the fluid. Point number 2, when the weight of body is equal to a thrust on it, the body float just inside the surface of the fluid, that is just touching the water surface. Submarine is shown here in the figure. It is just touching the outer, that is upward surface of water and floating there. In this case, apparent weight of body is equal to 0 because upthrust becomes equal to weight of body. Point number 3, when the weight of body is less than upthrust on it, then the body float partially above the fluid surface. Example, a ship or a wooden boat float in water and it remains outside, that is in air. In this case, we can check also weight of body is equal to upthrust. Figure 2 shows here the persons moving on water surface. They are inside the balloon and here is surface area is increased. On increasing surface area, the water displaced becomes more than the weight of the person inside this balloon. Therefore, they can move on water surface without going inside water because upthrust becomes more than weight of displaced water. Immiscible liquids. There are 3 liquids: vegetable oil, water, corn syrup. If we are mixing all the 3 by vibrating the vessel and keep it for some time, then vegetable oil comes at the top, water in between, corn syrup at the bottom. This is due to difference in density. Density of vegetable oil is less, therefore it is at the top, then water is more and corn syrup is highest, that is at bottom.